Hello, and welcome to Maths with El Profelo. Doing some elementary number theory here, using the text by James K. Strayer as a reference. We're going to be talking about linear congruences in one variable. Okay, so we have a definition that if a, b, and m are integers, where m is positive, then a congruence of the form ax is equivalent or congruent to b mod m is said to be a linear congruence in the variable x. Okay, and we say that it's linear because x is to the first power. Now, in solving, we're interested in finding all integer values of the variable, so all integer values of x, for which the congruence is true. If one element of a congruence class is a solution, then all elements of the congruence class are a solution, right? So, for example, if m were equal to 3 and x equals 1 were a solution, then 1 plus 3, x equals 4 would be a solution, and 4 plus 3, 7 would be a solution, but we'll look at that information later. Okay. Now, we have a theorem that says if we have this linear congruence, ax is equivalent to b mod m, and d is the greatest common divisor of a and m, then if d does not divide b, right, so if the greatest common divisor of a and m does not divide b, there are no solutions to the congruence in integers, okay? And that's due to the division algorithm. Now, if that greatest common divisor does divide b, right? If that greatest common divisor does divide b, this remainder, then the congruence has exactly d incongruent solutions modulo m in z. Okay? And we'll look at this example shortly to explain what that means. Now, we have a corollary to this theorem that says that the linear congruence in one variable, ax is equivalent to 1 b mod m, has a solution if and only if the greatest common divisor of a and m is equal to 1. And that's because the only positive integer that divides 1 is 1. Okay? Now, any solution of ax equivalent to b mod m is said to be a multiplicative inverse. And actually, this should say any solution to ax is equivalent to 1 b mod m is the multiplicative inverse, because that's how we define our inverse. It's the solution to ax is equivalent to 1 mod m. Okay, so our examples. And so once again, that should be a 1. Okay, the congruence 2x equivalent to 3 mod 4 is a linear congruence in the variable x. The possible remainders associated with the 4 residue classes, because I'm having this modulo 4, are 0, 1, 2, and 3. Okay? Now, since the greatest common divisor of 2 and 4 is 2, and 2 does not divide 3, there are no solutions to the congruence. There are no integers x, right, that when I take 2 and I multiply by that integer, I will have 3 left over in division by 4. Okay, and you can play around with this to have it make intuitive sense if you need. Now, consider the congruence 2x is equivalent to 3 mod 5. Right? Well, the possible remainders on division by 5 are 0, 1, 2, 3, and 4. These represent the possible solutions to the congruence. Okay? Now, by inspection, only x equals 4 is a solution. Now, how do we know there's only going to be one solution? Or even that there's a solution? Well, I look at 2 and I look at 5 and I say, what's their greatest common divisor? That greatest common divisor is 1 because they're relatively prime, because they're 2 prime numbers. And we know that if they're relatively prime, then 1 will for sure divide whatever this is, and 1 does divide 3. Right? So we have a solution, but it's only going to be one solution, which implies that one incongruent solution modulo 5. We can verify that x equals 4 is a solution by saying, hey, 2 times 4 is 8, which has 3 left over on division by 5. Okay? Now, all our solutions then will be 5 away from 4, meaning that all of our solutions would be able to say, hey, I could have 2 times 9. Well, 2 times 9 is equal to 18, and that's going to leave a remainder of 3 on division by 5. Right? And similarly, if I took and I subtracted, right, if I subtracted 1, and I said, well, what about 2 times negative 1? That's equal to negative 2, and that's going to be 3 mod 5, right? And the reason, right, let me split that up, excuse me. The reason it's going to be 3 mod 5 is that if I add 5 to negative 2, I'm going to have 3 left over. Okay. Now, next one, the congruence 2x is equivalent to 1 mod 5 has a solution because 2 and 5 are relatively prime, like we said, and 1 divides 1. In fact, this is this corollary, right? Now, since 2 times 3 is 6, and that's equivalent to 1 mod 5, we say that 3 is the inverse of 2 modulo 5, right? Because the solution to 2x equivalent to 1 mod 5, that solution is the multiplicative inverse, right? So this congruence relation, because 2 and 5 are relatively prime, will have a solution. That's the only way it'll have a solution when this remainder is 1. And that solution is called the inverse. Okay? And one more. The congruence 3x is equivalent to 6 mod 15 has solutions because 3 and 15 have a greatest common divisor of 3, and 3 divides 6. So we have solutions. How many solutions do we have? Well, we have the greatest common divisor number of solutions. There are 3 incongruent solutions, right? That is the information in this theorem 2.6. If the greatest common divisor divides B, then the congruence has exactly D incongruent solutions. Okay, so there are 3 incongruent solutions. All right. So stay tuned to find all solutions of 3x is equivalent to 6 mod 15 and other similar congruences. All right. This has been Maths with El Profe Lo. Look forward to continuing to work with you.